In this lesson, we're going to continue on with how to solve exponential equations with the same base. So if you recall from the last lesson, we said as long as those bases are the same, we can set the exponents equal to each other and solve. So in our first example here, we have 2 to the 3x plus 1 power equals 2 to the 2x minus 4 power. We can see the bases are both 2. So all we have to do is set the exponents equal to each other and solve. Move the x's to the same side, move the constant over, and we get x equals -5. We can check it by putting it back into the original equation. Problem number 2, again, we can see the bases are the same, so we only have to set the exponents equal to each other and solve, and then we can check it. But what if the bases aren't the same? So we had a few in the last lesson where that was the case. Well, what if we had the situation on both sides where we don't just have to rewrite one side? So in this case, our bases are not the same. We have 4 and 32. We know that 4 is 2 times 2, or 2 squared, and 32 is 2 to the 5th power. So now we can rewrite this as 2 squared instead of 4, but we still have to the x plus 6 power and 2 to the 5th. By rules of exponents, we know when we have a power to a power, we multiply. So we end up with 2x plus 12. Now that our bases are the same, we can set those exponents equal to each other and solve. So we get x equals -7/2. And once again, we can check it. So what are our rules for solving exponential equations with the same base? The first, determine how the numbers can be written using the same base. Rewrite the problem using the same base. Use the properties of exponents to simplify the problem. Once the bases are the same, drop the bases and set the exponents equal to each other, and finish solving the problem by isolating the variable. Here are a few more examples. We have 4 to the 3x plus 2 equals 8. Again, 4 and 8 are not the same base, so we rewrite in the base of 2. Power to a power, we multiply, and we end up with 2 to the 6x plus 4 equals 2 cubed. And we solve, and we end up with x equals -1/6. 3 to the 2x minus 4 equals 81. Well, here we only have to rewrite one side, and we'll have 3 to the 4th for 81. Set those exponents equal to each other, and you get x equals 4. A few more examples. 2 to the 4x plus 2 equals 1/8 to the 6th power. So once again, we'll go to the base of 2. But 1/8 is 2 to the -3, but we still have to the 6th power. So remember, multiply those exponents, set them equal to each other then, and solve. 8 to the 2x minus 6 is 1/16. Again, we can go to the base of 2. Use our power to power rule, and then set those exponents equal to each other and solve. 8, we have to rewrite both sides to the base of 2. And on both sides, we have to use the power to power rule before we can set those exponents equal to each other. And once again, we can solve, and we get x to equal 19/6. Some of these won't turn out very pretty, but they still work. Here we have 25 to the 2x minus 1 and 125 to the 3x plus 4. Again, we rewrite in the base of 5. So 25 is 5 squared, 125 is 5 cubed. Use our power to power rule to multiply, then set those exponents equal to each other, and we get x equals -14/5. And our last example is 16 to the 3x minus 4 and 64 to the x plus 1. Again, not the same base, so we need to rewrite in the lowest base. 4 squared is 16. 4 cubed is 64. Use our power to power rule. Then we can set those exponents equal to each other, and we end up with x equals 11/3. So again, today you're going to be trying more difficult problems than you did in the last lesson, where both sides may need to be rewritten, and you may have to use rules of exponents in order to solve. So good luck today. If you have any questions, be sure to reach out to your teacher, and we will be happy to help you.